Hi, boys and girls. It's Miss Bissell. We are working with our second lesson in topic 13, working with numerical expressions. So I would like you to please turn in your books to page 542. So yesterday we worked on our order of operations, and we learned that when we are solving a numerical expression, and don't forget, a numerical expression is simply a mathematical sentence that contains numbers and at least one operation. So the order of operations helped us out because when we had multiple operations, we needed to have a consistent set of rules so that we would know which operations we needed to do first. So if we had a numerical expression like the sum of 9 and 7, I don't know, divided by 2, let's see, times 3. So if this was our numerical expression, what we learned yesterday is that order does matter, and we have a set number of or set number of steps that we need to look at to evaluate. So if we take a look at this, first of all, we need to evaluate whatever's in the grouping symbols. And we have two kinds of grouping symbols. We have parentheses and we have brackets. So we always start with the innermost set of grouping symbols, which would be the parentheses. So 9 plus 7 is 16. We've evaluated it. The parentheses disappear. We bring down all the other symbols and numbers, and we have this. We still have a grouping symbol, so we need to take care of 16 divided by 2. 16 divided by 2 is 8, and 8 times 3 would be what we're left with to evaluate the answer as 24. All right, so that would be one answer, or I'm sorry, one situation. Another situation might be where you have problems such as this. So if you had this numerical expression, all right, of course we start with the grouping symbols, and the value 2 times 3 is 6. Then we have divide by 2 times 5. Now, we're going to have to move down. Unlike our other problem, we have to move down to our other steps. So our next step is to take care of any multiplication and division working left to right. So I'm seeing 6 divided by 2 and 2 times 5. So I need to take care of 6 divided by 2, which is 3. And that leaves me 3 times 5, which is 15. The last steps are, of course, the addition and subtraction if we had any. So let me do one more that would have those steps incorporated in it. So why don't we just take this problem. There we go. All right, added to it. So we're going to start with the grouping symbols. The only grouping symbols we have is 2 times 3. So we would bring down the 1 plus, the 6, divide by 2 times 5 minus 2. All the other symbols and numbers have to come down. Now we're working on the multiplication and division, working left to right. So we're going to have to start with 6 divided by 2. So everything comes down. All right. Next, we take care of all multiplication and division. So I still see some multiplication here. So that's going to be 15 minus 2. And now we've taken care of all multiplication and division. So our last step is addition and subtraction, working left to right. So start right here. I get 16 minus 2. This expression evaluates to 14. All right, so that's a good review of what we did yesterday. All right, for today, you can write in your book. You're going to need your calculator that I gave you, just your little basic 4-function calculator. We have a couple decimals. If we need to evaluate anything with decimals, you're going to need that because I have not taught you how to multiply, add, or subtract, or divide decimals yet. The other thing that you need is your book to page 542. So our question today, our essential question that we are going to use to guide us through the lesson and also look back on to make sure we have a basic understanding of what we're doing, is how can you write a numerical expression to record your calculations? So we're actually writing them. So we're going to start with the example on page 541. Go ahead and put your date today at the top of the page. And we have a baker who packages 12 cupcakes to a box. So we have 12 cupcakes in a box, a dozen. Sean orders 5 boxes for his sister's graduation party and 3 5/10 boxes for a variety show party. Write an expression that shows the calculations you could use to find the number of cupcakes Sean orders. All right, so here's a beautiful box of cupcakes. There are a dozen, 12 in the box. Now he orders 5 boxes, this is important to know, for the graduation party, and he orders 3 5/10 boxes for another party called a variety show party. And we're going to write an expression that shows how we would solve this. All right, so let's think about that. There are 12 cupcakes in a box. So I'm thinking if we buy the cupcakes for the graduation party, we need 5 boxes. Each box has 12 in it. So wouldn't that be how we find the number of cupcakes in those 5 boxes? And then we're going to add to it what he orders for the variety show. Again, there are 12 cupcakes, so we're doing 12 cupcakes, but this time he's not ordering an even number. He's ordering 3 5/10. All right, so step back, think about that a minute. We're adding order 1 for one party to order 2 for the other party, right? 12, a dozen in each of the boxes, so 5 groups of 12 or 3 1/2 groups of 12, and then we have to add them together. All right. So when we multiply 12 times 5, we know that that is 60. All right. I have not taught you how to multiply yet, so if you want to grab your calculator, and don't forget, you're writing this in your book with me, so if you need to pause me at any time, you can. 12 times 3 5/10, I get 42. All right, so to find the total number of cupcakes, 60 and 40 is 100. And 2 more would be 102 cupcakes. All right. So we have written a numerical expression to show how to solve this problem. And I think I took it one step further and I went ahead and solved it with you. All right, let's look at the look back. Write a different expression to model Sean's order. All right, it does tell us to evaluate both expressions to see that they are equivalent. Equivalent simply means that they are equal, which they should be. And then the bottom line is, how many cupcakes did he order? So if we did our work right, we should get 102. So think of how we could break this up a different way. All right, so he's getting 12 cupcakes in a box, and he's ordering 5 for his sister's graduation party and 3 5/10 boxes for the variety show party. So I'm thinking if I add the 5 boxes for the graduation party to the 3 5/10 boxes, then I know he's getting 8 5/10 boxes, or 8 1/2 boxes, right? And there are how many cupcakes in each box? 12. So I'm thinking, why don't I multiply by 12 the sum 5 and 3 5/10. So he's actually ordering 8 5/10 boxes of cupcakes. So that is going to be 8 5/10 groups of 12. So again, I haven't taught you how to multiply decimals. So take your 8 5/10 in your calculator, multiply it by 12, and you should get the answer 102 cupcakes. Okay? 102 cupcakes. So look at that a minute. Okay. Those are equivalent expressions. There are 2 different ways to write the expression. All right, we're going to go to page 542, and this is your visual learning example. if you're working on your practice buddy today and you click on the eye icon to get help and they show you a video, this is usually the video you're going to see about this problem. So the school auditorium has 546 seats in the main floor and 102 in the balcony. All right, so 546 on the main and 102 in the balcony. Every seat is filled for all of the variety show performances. Write an expression that shows the calculations you could use to determine how many tickets were sold. So every one of those seats is filled up. Now, the question wants to know, write an expression to show the calculations of how many tickets were sold. All right, tickets are $4.50 a piece. That's not going to help me, but there are a couple performance dates. Okay, so let's look at that. We have Friday, March 18th. We have 2 on Saturday, a matinee and an evening, and 1 performance on Sunday. So that information is going to help me because every seat is filled for all of the variety show performances. So I don't need the price. That doesn't help me. But to determine the number of tickets, yes, I need this information from the poster. So we're going to think about how you would calculate the total number of tickets. So the thought is, if you add the number of main floor to the number of balcony seats to find the total number of seats, then you could take that sum and multiply it times those 4 performances. Remember, for each performance, the seats are all filled. All right, so we're going to write a numerical expression that represents find 4 times the sum of 546 and 102. So we're going to use the numbers and symbols to write that. The sum of 546 and 102 is written just like this. And when we multiply it by 4, what we're going to do is we're going to go ahead and put parentheses around the balcony seats, how many there are in the balcony and how many there are in the main floor, so that we get a sum first. And once we have a sum, or the total number of seats in the whole auditorium, then we can multiply it by 4. Remember, those parentheses are used to show what operation to do first. So we want whoever solves this problem, the way we write it, we want them to add the total number of seats in the balcony with the main floor to get the total number of seats in the auditorium. Okay? And then we multiply that by 4. All right, the boy even reminds us, the parentheses show which calculation to do first. The expression 4 times the sum of 546 and 102 shows the calculations for the number of tickets. All right. So I want to move on over and work on a couple questions and just kind of dip our toes in this. We're going to cycle back through what we did yesterday and what we're doing today when we come back to school next Tuesday and Wednesday. So we are going to see this again. So don't think that this is going away. All right. So the question is, why do some numerical expressions contain parentheses? And we kind of just talked about it over here. The parentheses are used to show us what calculations to do first, especially if we want to add or subtract first, and we've got multiplication and division as part of our numerical expression. Because without the parentheses, wouldn't we have to multiply or divide first? So let's jot that down, that the parentheses are one way to show which calculations need to be completed first. And again, I keep saying it, and some of you just don't listen. You need to pause the video and make sure that whatever problems I'm working out, whether it be in the book or on paper, you're doing the same thing so that you have a good set of practice problems when you sit down with your practice buddy. All right, so we're going to show how to use a property to write an equivalent expression for 9 times the sum of 7 and 44. All right, can you use a different property to write another equivalent expression? So I am thinking about that distributive property, and we used it with the cupcake, and I didn't even point it out. But if I wanted to break this apart, then what I could do is, instead of multiplying the sum of 7 and 44 together by 9, couldn't I multiply 9 times 7 and add it to the product of 9 times 44? So see if this looks familiar. You guys worked on this a little bit last year. So if I multiply 9 times 7 and I add it to the sum of 9 times 44, then with the distributive property, really what we're doing is we're doing 9 times the sum of 7 and 44. Okay? Now, we could do something else. That is using the distributive property, so let's make a note there. And I'll give you a second to write that down. And then if I'm moving too fast, then you boys and girls can definitely pause me. All right, but with the distributive property, we're just breaking up those larger numbers. All right, now another property we could use, let's see if this one looks familiar. We could actually multiply 9 times the sum of 7 and 44. That's what we had written above here, right? And we got that from there. But wait a minute. If we used the commutative property of addition, then we could switch these add-ins around. We'd still be multiplying 9 times the sum, but couldn't we switch these add-ins around? And won't this give me the same answer, right? And that is using the commutative property of addition. All right, we're going to have a poster. We're going to have a handout in our book on page 54 in our math journal, that shows these properties. And we'll be talking about these more when we are face-to-face again. All right, so we are going to write a numerical expression for each of these calculations. So this is where we really have to read carefully, and there's a couple key words we have to know. We have to know that the sum is talking about the answer to an addition problem. We have to know the word difference is the answer to a subtraction problem. We have to know that the word product is the answer to a multiplication problem. And we have to know that the word quotient is the answer to a division problem. Because we're going to see some of these words that are going to be a clue to me that I'm going to put these operations in parentheses. Because if you're looking for the sum of something, then that means you need to go ahead and add it together. So yes, we need to put parentheses around it to tell somebody, go ahead and add that together. So you'll see this as we work through a couple. All right, so we're going to add 8 and 7 and then multiply by 2. I almost feel like I'm teaching English every time I teach this lesson, because there's word clues that tell you what order to do things in. And if I tell you to put on your socks and then put on your shoes, then don't the shoes go on last? Of course they do. That would be silly to put your socks over your shoes. So in this case, it tells you to add 8 and 7. So that looks like this. And then it wants you to multiply by 2. So think about this. We have to add first. If we follow those order of operation rules, really, if we wrote it like this, then wouldn't we have to multiply 7 and 2 first? So what we need to use to kind of override the rules is we need to use the grouping symbol, parentheses. Remember, those parentheses tell us what to do first. All right, so look at that. Are we representing this correctly? Are we telling somebody to add 8 and 7 and then, which would indicate after they do that, multiply by 2? And the answer would be yes. All right, number 4, we're going to find triple the difference between 44 and 75 hundredths and 22 and 8 tenths. Oh, quite a bit of vocabulary there. Triple means 3 times, right? 3 times something. All right. Difference means the answer to a subtraction problem. When I see one of these words, sum, difference, product, quotient, and then I see the numbers I'm subtracting, then that's going to tell me I'm going to want to put that in parentheses so somebody can find the difference and triple it in this case. So let's work with that. The difference would be of 44 and 75 hundredths and 22 and 8 tenths. So if I put that in parentheses, then I'm telling somebody that they need to find the difference of those numbers. And again, I have to know that that means subtract. Then if we're going to triple it, it doesn't matter where I put times 3. I could do 3 times right here, or I could put it in the back. It is not going to make a difference in how it's solved and what my value is going to be. Okay, so it can go either place. So go back and look at that one. Find triple the difference. So we have to find the difference of these numbers, 44 and 75 hundredths and 22 and 8 tenths. Find triple the difference. So once we have the difference, we triple it. All right, look at number 4. Multiply 4 times 7/8 and then add 12. That's very much like number 3. We don't want to add the 12 to the end, okay? Again, think of your shoes and socks. I'm going to tell you to put your socks on and then your shoes, right? So your shoes go over your socks. So the then add 12 is going to be the last thing I do. So if I multiply 4 times 7/8, that's what it's going to look like, right, boys and girls? And then add 12. So let's look at this a minute. I'm wondering, do I have to use the parentheses? So I'm going back to yesterday's lesson. If I want to multiply this first and then add 12, do the order of operations have me do multiplication before addition? And the answer is yes. So if that's the case, I really don't need parentheses because the order of operations is telling whoever's solving these numerical expressions that you always divide and multiply before you add and subtract. Now, as a courtesy, could you do this? Absolutely. So if you want to put parentheses around it, it's not going to make it wrong. You're going to evaluate it and have the same answer, but it's not required because due to the order of operations, you would be multiplying before you add it anyway. All right, let's look at number 6. Add 49 to the quotient of 125 and 5. So here's one of those words that is an answer to a division problem. So remember what I said earlier? When I see this word with the numbers that I'm, in this case, dividing, I will go ahead and put those in parentheses. So we're dividing 125 by 5. Okay, so when I see sum, difference, product, or quotient, I usually put that in parentheses. And it says add 49 to it. So if you add something to something, then here we go, it's an English lesson. Aren't we assuming you already have something there that you're adding the 49 to? So in this case, I would put the 49 at the end. It's not going to be incorrect if you wrote it this way, because you're going to be dividing first and then adding, so you're going to get the same answer. So either way is okay, but when I really break down what the English language says, especially with these prepositions, then I'm assuming that I've got something already there in parentheses that's being divided that I'm adding 49 to. See that preposition to? All right, now let's look at a couple more. I know this is a little weird because it's almost like an English lesson, grammar lesson, specifically inside your math lesson. So number 7, we're going to add 91, 129, and 16, and then divide by 44. That and then tells me that that's coming at the end. Remember, back to those shoes and socks. You don't put the shoes on, all right, until you put the socks on. So you put your socks on and then your shoes. So we're going to add these numbers. So we have 91, we have 129, and 16. Now, if we're going to add them together and then divide, we've got to be careful about something. All right? If I don't put these in parentheses, then the order of operations would tell me I'm going to divide 16 by 44 as my first step, right? Because without any grouping symbols, we take care of division and multiplication before subtraction and addition. So I am going to put these in parentheses. So once I add these and have a sum, then I'm going to divide that sum by 44. Okay? Number 8, we're going to find 8 and 5/10 times, that means multiplication, right? The difference is one of those words that means the answer of a subtraction problem. So I'm going to find 8 and 5/10 times the difference between 77 and 13. So there's that word that means an answer to subtraction. So to get the answer to the subtraction, I'm going to put 77 minus 13 in parentheses. There's my expression that would give me the difference, right? And then we're going to find 8 and 5/10 times it. So we can do 8 and 5/10 at the end. We would be subtracting first. And without those parentheses, think about it. Without the parentheses, you would be multiplying 13 times 8 and 5/10, wouldn't you? And then you would be doing a subtraction. And so we have to be very careful to think about some of these things. So subtracting would be finding the difference. We're using 77 and 13. Now, it would be perfectly okay if the 8 and 5/10 went to the front. You're going to get the same answer, right? Either way, the value is going to be the same of your expression. All right, look at number 9. We're going to subtract 55 from the sum. Oh, here's that key word sum. That means we're adding these two numbers together, 234 and 8. We're subtracting 55 from it. So quick English lesson, if we subtract something from something, put a big asterisk here, then you have to have this first so you can subtract from it. Think about that. Okay, so the sum of 234 and 8 would be found by putting those in parentheses and adding them together. Once you have the sum, then you're going to subtract from the sum 55, right? Subtract 55 from the sum. So that 55 has to go to the back. That is non-negotiable. You cannot write it this way. 55 minus the sum of 234 and 8. That is not the same thing. You're going to get a totally different answer. As a matter of fact, you're going to be in the negatives. And we don't do negative numbers in 5th grade. All right. This right here is going to give you way more than 55. So when you take it away, you're going to be in the negatives. This is taking the sum of 234 and 8 away from 55. That is not what those words say. I'm going to put a star there because I see this all the time on benchmark and state tests. They love to put this there with a subtract from, and inevitably kids will do 55 minus the sum of 234 plus 8, and it just doesn't work that way. If you take something from something, you have that other something already down first. Okay. Number 10, multiply 2/3 by 42 and then multiply that product by 10. Oh, so we're going to multiply 2/3 by 42 to find the product, right? So 2/3 times 42 would be how we multiply 2/3 by 42. Because the word product tells me that I'm looking for the answer to a multiplication problem, I'm going to put that in parentheses. And it says, and then multiply that product by 10. So just like the other and thens, you're going to have to, you're going to have the expression in parentheses written first, and behind it, you're going to multiply that product right here by 10, just like that. Does that make sense? All right, number 11, write an expression to show the calculations you could use to determine the total area of the right rectangles at the right. All right, so I get that we could do 18 times 22. We could do 18 times 22 for this one. Add it to 18 times 22, areas length times width, right? And we could add it to 18 times 22 for the last one, right? So we could do that. Or couldn't we? Another way, don't we have 3 equivalent rectangles? So if we found the area of one, couldn't we just multiply that area by 3? So if we have 3 rectangles and each of them measures 18 centimeters by 22 centimeters, I like this expression, and I am sorry, I'm off the paper here. I like this expression because I can show that I am going to have 3 groups that measure 18 by 22 centimeters. So either way would give me the same expression, right? This one, I think, a little bit less work. All right, I'm going to look at just a few of these on the back. There's just not a whole lot of problems with this. So like I said, next week we're going to cycle back and we're going to work with evaluating expressions using the order of operations, and we're going to even cycle back with this concept, and we're going to write numerical expressions. We're not even calculating these, are we? All right, I just had that calculator for that first problem. All right, number 12. Let's work this one out. Ronnie's Rentals charges $25 plus $15 per hour to rent a chainsaw. David rented a chainsaw for 5 hours. So we're going to write an expression to show how you could calculate the total amount David paid. All right, so let's dig back through here. So you're paying a charge of $25 plus $15 per hour. So we're starting with a $25 fee just to rent it. And on top of that, plus we are going to pay $15 per hour, and the number of hours is 5. So $15 5 times, couldn't we do 15 times 5? Now, we don't have to have parentheses because we would multiply before we add, following the order of operations. But I'm going to set it up like this because I think it makes it very clear to my reader that they can quickly multiply 15 by 5 and then just add 25 to that product. Okay? And that's how we would figure out how much David paid. We don't even have to figure out how much he paid. We're just writing the expression, right? All right, let's look at number 13. 14 students bought their art teacher a new easel for $129. Wow. And a set of blank canvases for $46. Sales tax was $10.50, and they shared the cost equally. If you share a cost of something equally, aren't you dividing that cost up among the number of people? So doesn't that mean at some point when we get the cost of all these awesome art supplies, aren't we going to divide it amongst or between 14 students? All right, so we're going to write an expression to show how you would calculate the amount each student paid. So what are they buying? All right, they're buying a $129 easel. They're also buying, so I'm going to add, because when you go to the cashier at the register, they total up your purchases by adding them, a $46 set of blank canvases, and you have to add your sales tax of $10.50. So when all that's added, so let's go ahead and put parentheses around it. Once you have the total or the sum of those awesome art supplies and the students are sharing this total equally, then aren't we divvying it up or dividing that total cost between the 14 students to solve the problem? And we've written a beautiful numerical expression to solve it. All right, I love this question. Everybody should be able to answer this. When evaluating an expression, why is it important to use the order of operations? And we saw that in class. If you were in class with me yesterday, we solved a problem without any knowledge of the order of operations, and we got different answers. So if we want everybody to get the same value for an expression, don't we have to have a given set of rules? Absolutely. So the reason we use the order of operations and the reason we follow them is so that everyone gets the same value for the expression, for any expression, right? And I was telling the kids at school yesterday, and your parents can relate to this. Sometimes on Facebook, people will put a numerical expression on Facebook. Yes, that sounds funny. They'll just post one and ask people what they get. Just kind of a fun game to see what people get. And it is hilarious to read what people write, because adults that are trying to solve some of these problems, even something as simple as this, without the parentheses, will argue over their answers. And it's just so funny. All right, number 15. A storage, we don't need to do that. This is volume. The last one I wanted to look at were down here. So these are the kind of problems that you might see on a multiple choice test that deal with today's concept. So which expression represents the following phrase? We're going to subtract 214 from 721 and then divide by 5. All right, thinking of those shoes and socks, and then divide by 5. So the last thing we're going to do is divide by 5. But what are we going to divide by 5? Oh, we're going to subtract 214 from 721. So doesn't that mean we're going to have 721 that we're going to subtract 214 from? Let me make myself some more room. So think about my little English lesson here. Okay, little grammar lesson. We're subtracting 214 from this number, and then we're going to divide by 5. So wait a minute. Due to the order of operations, I can't leave it like that, because I would be dividing, right? And then I would be actually subtracting the quotient of 214 and 5. So in order to tell tell my students that might be solving this that I want them to subtract 214 from 721 and then divide, then I have to put parentheses there so that the subtraction is done first. Without that, subtraction would be done after division without the grouping symbol. So the only answer that works is D. All right. Probably the one that you would pick that you would miss it would be B, and that's because without the parentheses, you would not be dividing last, and you wouldn't even be subtracting 214 from 721, because you would be dividing first and have a totally different number there. And I like number 18. I see this a lot. What is the first step in evaluating this expression? So you have parentheses with addition in it, you have multiplication, and you have subtraction. So think back to your order of operations yesterday. Step one is you take care of any of your grouping symbols. So if you have parentheses, or if you have brackets, or if you have braces, any of those, you do those first. and I see that you do have parentheses. And in it, it tells us to add 47 and 122. So we have to do that first. The parentheses override doing multiplication before addition, right? All right, boys and girls. So I know that we didn't have a whole lot of problems. There's not a lot of meat in this lesson, but it's enough to dip your toes into the concept. We're going to cycle back, like I said, next week and work on this some more. So we are at a point where you should be able to write a numerical expression to record the calculations. So yes, you have to have knowledge of yesterday's lesson. So you have to have worked through lesson 13.1 and understood the order of operations right here on page 538. And then you have to use a little bit of common sense and a lot of English skill knowledge, especially with those prepositions. All right. So let's see how you do. You have a practice buddy. Work on your practice buddy. Don't forget you have one Dreambox lesson to complete per day, and you have 2 of your weekly review 9 problems that you need to work on. All right, boys and girls, have a wonderful day, and I will see you soon.